Okay, we're going to continue part 2 of chapter 4, the second half of chapter 4, where we're looking at the graphs of cosine this time and its inverse. So let's first go over to come up with a circle, unit circle, and just again how this works and why it works. Let me slide this down a little bit, and hopefully this makes a little more sense than some of us were confused the first time we did it. And again, each time we look at it, hopefully that helps us get better and better at it. Okay, so there's my y-axis and my x-axis. First of all, cosine of theta equals x over r, and we know from SOHCAHTOA, again, quick little way of remembering that, it's adjacent leg all over the hypotenuse. What does that mean? Let's look at this. So there's our terminal side, there's our angle. We draw the triangle back to the x-axis. So there's theta right there. So adjacent leg is right over here. That's also the x value when I'm looking at a point on the unit circle. That's always xy. The y value, which is the opposite leg, which has nothing to do with cosine, is again represented by the y-coordinate, and our hypotenuse is always the radius. So how does this help us? Well, we have 0 degrees, which is also 360, and I'll talk about some of the negative values. Here's 90 degrees, which is pi over 2. Here's 180 degrees, which is pi, and here's 270. Okay, so now what are we doing here? First of all, let me label some of our graphs. We're going to go from negative 2 pi to 2 pi. I'm actually going to make my y values a little bigger. We're going to go from positive 1 to negative 1. So let's graph this. All right, well, at 0 and 360, x has a value of 1, and we're talking about a unit circle with radius 1. So at this point right here, x is 1, y is 0. Well, we know the radius has to be 1 because it goes to the edge of the circle. So x is 1, r is 1, 1 over 1 is 1. So when x is 0, let me change markers here. When x is 0, we get y is 1. And that's also going to be at 360, which is 2 pi, because 0 and 360 are the same. And that's also going to be negative 360 degrees, which is negative 2 pi. Okay, so now let's move up to when we're at 90 degrees. Well, now x is 0 and y is 1. Well, y has nothing to do with this. X is 0. 0 over anything is going to be 0, and we know the radius is 1 or the unit circle. So when I'm at 90 degrees, which is pi over 2, I'm going to have a cosine of 0. And I should know 90 degrees is also the same as negative 270 if I went clockwise, which is negative 3 pi over 2. So right here will also be 0. Okay, let's find 180. 180 is pi. That's going to be x is negative 1, y is 0. Again, I go to the left 1, I go up 0. So cosine is going to be negative 1 over 1, which is just going to be negative 1. So cosine of pi is negative 1, and 180 degrees is the same angle as negative 180 degrees. Those have coterminal sides. Okay, and let's go to our last one here. This is going to be 0, negative 1. Once again, x is 0 on the y-axis, so cosine is going to be 0. So let me mark these down. So at 3 pi over 2, we're going to have 0, and I should know that this has a coterminal angle of negative 90, which is negative pi over 2. And we can start to see our periodic function. And obviously my graph's not going to be as good as the graph in the book. A little bit better than what I did for sine. So this is the graph of y equals cosine x. Next, let's take a look at the inverse. So as we look at y equals inverse cosine, another way to say this is arc cosine x. First of all, in order to make this a function, I have to put a restriction on the original function y equals cosine x. and that restriction is going to be from 0 to pi. So therefore, and I didn't write this down, the domain of the inverse cosine is going to be from -1 to 1, and our range is from 0 to 1. So let's go back and look at what I'm doing here. So I'm going to put a restriction on this from 0 to pi. That's the graph I'm looking at. And let me get some values here. So I know when x was 0, y was 1. When x was pi over 2, y was 0. And when x was pi, y was -1. So let's just take those 3 points and take a look at what that does. So when we look here, again, I had, and let me first draw our domain and range. So now I'm going from switches. So this is from -1 to +1. This is going to be pi and 2 pi, and this will be -pi over -2 pi. So what we're looking at here, our domain is going to be from -1 to +1, but we're only going from 0 to pi. So this is going to change dramatically what our graph is going to look like. So we said back here, 0, 1 is on the graph. So now when I come down to the inverse, I'm going to have 1, 0. That will be right here. Looking back at our original cosine function, pi over 2 is 0. So now when I take the inverse, that's always switching the x and the y. I'm going to end up with 0 pi over 2, which will be right here. And look back at our original cosine function, pi -1. This is now going to give us -1 pi. And as I graph this, again, it's going to be a little bit steeper at the beginning, and then flatten out, and then get steep again at the end. So that's our graph for inverse cosine x, which again, we're just taking the parts of y equals cosine x, switch the x and the y, and obviously now we're going to just take a certain part of the original cosine function right here from 0 to pi, so that it is 1 to 1. So now the inverse of that will be a function as well. Okay, and that's our graph of y equals cosine x and its inverse.